We did adding and subtracting fractions. Now we're going to do multiplying and dividing fractions. Now, actually, the multiplying of fractions is a lot easier because we don't even have to find a common denominator. We can just forget about that step. We don't need it. Isn't that awesome? Yeah. So, multiplying fractions. It says on average, people spend 1/3 of their lives asleep. About 1/4 of the time they sleep, they dream. So what fraction of a lifetime does a person typically spend dreaming? So you take, it says 1/4 of something. Basically, it's just saying multiply 1/4 times whatever that something is. So this something is 1/3. So it's asking us for 1/3 times 1/4. Well, it's this simple. Multiply the numerators, multiply the denominators. 1 times 1 is 1. 3 times 4 is 12. Okay? So the answer is 1/12 of their lives they spend dreaming. All right? There is one other little trick to it, and I'll get into it in a little bit. But ultimately, when you are all done, all you do is multiply the tops, the numerators, and the bottoms, the denominators. That's all you do. And then look to see if you can reduce. We don't need to do that. Okay? Now, here's the next thing. I just told you, all I got to do is multiply the numerators and multiply the denominators. So if you really wanted to, you could do this, and you could go 1 times 2 is 2, 4 times 5 is 20, and then you want to reduce. Okay, so top and bottom both can be divided by 2, right? And so you end up with 1/10. Now, let me tell you, and let me show you something that's going to help you do this. And I know a lot of you are like, oh, I don't really want to do that. It seems like it's extra work. But you know what it's going to do? It's going to reduce your risk of making a mistake because you're going to end up dealing with smaller numbers. Okay? So here's what you do. That way works. What I just did works. But here's what I would do first, and here's what you should do, and here's what I want you to do. The first thing you do is check numbers that are the diagonal of each other, the crosses. Okay? Is there any number that goes into both 1 and 5 other than 1? There isn't. Is there any number other than 1 that goes into 4 and 2? What is it? 2. So here's what you do then. Then you divide each one by 2. So you divide 2 by 2, which is 1, and you divide 4 by 2, which is 2. Then, once you've done that reducing, it's just basically reducing before you do the multiplication. 1 times 1 is 1. 2 times 5 is 10. We ended up with the same answer. We just reduced before we multiplied. Yes? What do you mean? Oh, you mean just go 1 times 2 is 2, and then 4 times 5? You can, but let me tell you this. You're going to end up dealing with larger numbers then. Okay? Whereas if you do this, you're multiplying 1s and 2s, and otherwise some of them are going to get a lot bigger. Okay? Especially when we start multiplying improper fractions. Because you're going to have large numbers on top. And then you're going to be multiplying double, even triple digit numbers. And I would much rather reduce ahead of time than reduce after. So why don't you guys write this one down on your whiteboard. 5/7 times 4/15. 5/7. Make sure you write 5/7. So with this problem, instead of multiplying 7 times 15 and 5 times 4, I'm going to check my diagonals. And right here, I can reduce both of these by 5. Divide by 5, this becomes a 1. Divide by 5, this becomes a 3. Then we multiply, we got 4 over 21. Okay? Then we look at this and make sure that what's the least common multiple that they have, or greatest common multiple they have, or what multiples, or I shouldn't say multiples, factors. Greatest common factor. Does 4 go into 21? Do they have any common factors other than 1? They don't. So this is in simplest form. All right. Let's go one more. With this one, please be aware. You got both. You got both here. You got 4 and 10, so you can divide this both by 2. So this can become a 2, and this can become a 5. And then you can do this one, divide by 3 here, so this becomes a 3, and this becomes a 2. You end up with 4 over 15. Because 2 times 2 is 4, 3 times 5 is 15. Okay? Much easier than recognizing, 24 over 90 and trying to reduce it there. I would really check. You are so much better off doing it ahead of time. You have problems that look like this. Evaluate the expression b times 2 over 5 for each value of b, and then write each answer in simplest form. Remember, all this is taking this number, b equals 1/3, and plugging it in there. So now you have 1/3 times 2/5. And there is no reducing. You can't. Nothing goes into 1 and 5 other than 1, and nothing goes into 3 and 2 other than 1. So we got 2 over 15 for that one. All right? Good with that? Okay. We're going to skip ahead here. We're going to talk about ones that look like this. 2. Now we're throwing another wrench in the system. What do we have to do first? Yeah, we got to rewrite this one. We got to make this into an improper fraction. We got 1/4 times 3 times 1 is 3 plus 1 is 4 over 3. Now check our diagonals. Well, 4 and 4, that's easy. 1 and 1. 1 times 1 is 1. 1 times 3 is 3. Now, there's a lot of you going to look at that. Hey, a lot of you are going to look at that problem and go, wait a second. I'm multiplying, and I've got a number here, 1 and 1/3, that's a lot bigger, and my answer becomes so much smaller. Why is usually when you multiply, doesn't the answer get bigger? Why would it be smaller? Xander? Because what? Fraction is less than 1. 1/4 is less than 1. So you're multiplying a number, 1 and 1/3, by a number less than 1. And when you multiply by a number less than 1, your answer is going to be less than the original problem. That's the way it is. Okay, so on your whiteboards, why don't you try this one? So 3 times 2 is 6, plus 1 is 7, so we got 7 over 2 times 4 over 5. Check our diagonals. We can go this. This becomes a 1. This becomes a 2. 14 over 5, then we need to reduce that. 5 goes into 14 2 times with 4 left. And keep our denominator. Good? Happy with that? See what the other problems look like. You mean this one? So we got 14 over 15 times 3 times 7 is 21. We got 23 over 7. Boy, would that be ugly if we don't check our diagonals, right? 7 and 14, we got a 1 here and we got a 2 here. Will give us 46 over 15. 15 goes into 46 3 times with 1 left. All right, here's what I want you to do for your homework. I want you to do page 266. $14 to 52 even.